February 1944. A bitter wind sweeps across the frozen plains of Michigan, but inside the walls of Willow Run, there is only heat, the heat of metal, of effort, of industry alive. Steam hisses through the air as sparks dance from welding torches. 1,000 hands move in rhythm, riveting, lifting, fitting. Beneath the high ceiling of the world's largest factory, a massive aircraft slowly takes form. The Consolidated B-24 Liberator. Every 63 minutes another one rolls forward, gleaming beneath the floodlights, its aluminum skin still warm from assembly. Shift whistles echo. Trains groan as they haul engines and wings toward the testing fields. In one corner, a young woman wipes the oil from her hands and watches as the bomber she helped build is towed out into the snow. Somewhere, thousands of miles away, that same machine will fly above the Pacific and change the course of a war. At the same hour, half a world away, Japanese engineers in a dim office in Tokyo examine aerial photographs. The images show hundreds of identical aircraft lined up across an American airfield. One engineer leans closer, tracing the rows with his finger, disbelief in his eyes. "Impossible," he murmurs, but it was not impossible. It was industrialized war. They built a B-24 every 63 minutes, faster than Japan could repair its runways, and that realization would soon shake the empire to its core. In Desai, the early months of 1942, as smoke still rose from Pearl Harbor, the United States faced an impossible task. It had to fight and win a two-ocean war against two of the most experienced military powers on Earth. But victory, Washington knew, would not be won by courage alone. It would be won by production. President Franklin D. Roosevelt called it the arsenal of democracy, and behind those words came a national transformation unlike anything in history. American industry, once the engine of automobiles, refrigerators, and farm tools, turned its gears toward war. The automobile plants of Detroit became the beating heart of the Allied effort. Steel mills ran without pause. Rubber, copper, and oil were rationed. Civilian goods vanished, replaced by tanks, shells, and aircraft. Among the industrial titans answering the call stood a company best known for cars, Ford Motor Company. Henry Ford, the man who had revolutionized the assembly line, now faced a new challenge. Could mass production build a warplane? The task seemed absurd. Airplanes were fragile, complex machines assembled by hand in small workshops. The B-24 Liberator, a long-range heavy bomber built by Consolidated Aircraft, was one of the most intricate designs ever made. 18,000 parts, 4 engines, and a 110-foot wingspan. Traditional aircraft factories could produce only 1 or 2 per day. But Ford saw potential in scale. In April 1941, before America had even entered the war, Ford signed a contract to build a new plant outside Ypsilanti, Michigan, a facility that would apply the same logic used to build millions of Model Ts to the art of aviation. The plan was simple but revolutionary. If a car could roll off an assembly line every minute, why not a bomber every hour? The site became known as Willow Run, a name that would soon echo through military and industrial circles worldwide. Construction began before blueprints were even finished. Bulldozers cut through farmland, raising a structure so vast it seemed to stretch beyond sight, over a mile long, with enough floor space to fit 80 football fields. At its peak, 42,000 workers would fill its corridors, producing aircraft on a scale the world had never seen. Inside, engineers rethought every step of production. They broke down the B-24's complex frame into modular sections, each assembled in sequence by teams specializing in wings, engines, or fuselage. Conveyor belts carried subassemblies through the plant like veins pumping steel and fire. Out on the test field, pilots waited for their turn to take the latest Liberator into the air. The first months were chaos. Ford engineers clashed with Consolidated's aircraft specialists. Bolts didn't fit, wiring failed, and entire planes had to be rebuilt. Critics mocked the idea of mass-produced airplanes as a fantasy. But by late 1943, the rhythm began to take hold. Training improved, procedures stabilized, and the factory roared into tempo. Day and night, the production line moved forward, a living organism of noise and motion. Men in overalls and women in bandanas stood shoulder to shoulder, riveting through fatigue, learning to think like machines. For many, it wasn't just work. It was participation in something vast, almost sacred. They weren't building cars. They were building power, mechanical wings that would cross oceans. By the start of 1944, Willow Run was no longer an experiment. It was a miracle of logistics and discipline. Every 63 minutes, another B-24 rolled off the line, tested, armed, and ready for delivery. America had done what no nation in history had achieved. It had turned air power into mass production. And across the Pacific, Japan was watching with growing unease. Across the Pacific, in the war-torn workshops of Japan, the contrast could not have been sharper. By 1943, Japanese aviation engineers faced a crisis. Their factories, once symbols of precision, were now crumbling under the weight of blockade and bombing. Aluminum was scarce, rubber nearly gone, and skilled labor increasingly replaced by students and conscripts. The Zero fighter, Japan's pride in 1941, had begun to lose its edge, not because its design failed, but because Japan could no longer build it fast enough or in sufficient quality to match the losses. Unlike America's mechanized lines, Japanese production remained bound to craftsmanship. Each plane was almost handmade, riveted, polished, and tested by specialists who valued precision over pace. In peacetime, that tradition had produced aircraft of stunning agility and beauty. In wartime, it became a burden. The Imperial Navy needed hundreds of planes a month. Most factories could manage a few dozen. While Ford's Willow Run delivered bombers like clockwork, Japanese plants like Nakajima and Mitsubishi struggled to replace even half of what was lost in a single battle. Every new airframe required rare materials imported across seas now hunted by American submarines. Every shipment risked destruction. Inside Tokyo's Ministry of Munitions, engineers and bureaucrats tried to calculate the impossible. Reports arriving from the front told of American bombers swarming over Pacific islands in formations so vast they seemed endless. Reconnaissance aircraft returned with photographs showing airfields in Hawaii, California, and the Marianas packed with rows of identical bombers, each one capable of leveling a city block. The figures were incomprehensible. Japan's total aircraft output for 1943 stood near 16,000 planes, fewer than the United States built in a single month that same year. But it wasn't just quantity, it was method. Where Japan's process depended on skilled hands, America's depended on systems, machines that never tired, workers interchangeable, and supply chains synchronized to the minute. Willow Run alone, a single American factory, produced more B-24 bombers than the entire Japanese aircraft industry produced heavy bombers in the entire war. Japanese engineers studied every photograph they could find. Some thought the Americans had exaggerated, that propaganda inflated the numbers. But when captured reports and POW testimonies began to confirm the scale, disbelief turned to dread. They realized that America's true weapon was not the B-24 itself. It was the ability to produce B-24s faster than Japan could destroy them. Meanwhile, American industrial leadership kept expanding. Ford's techniques spread to other companies, North American Aviation, Boeing, Douglas, creating a network of plants where parts from one state fit perfectly with assemblies from another. Wings built in California could attach to fuselages made in Texas, engines shipped from Ohio, instruments from New York. The nation itself had become one massive coordinated factory. In contrast, Japan's fragmented industries worked in isolation. The Army and Navy maintained separate aircraft designs, competing for resources, refusing to share technology. By the time Tokyo attempted to centralize production in 1944, it was too late. Allied bombers, many of them B-24s, were already overhead. The battle for air superiority was being decided not in the skies but on the assembly line. And on that line, America's machines had already won. The engineers in Tokyo could not yet know it, but the sound echoing across Michigan, the steady rhythm of rivets and engines, was the sound of their defeat taking shape, one bomber at a time. It was not a matter of courage. It was a matter of capacity. And soon that capacity would become a storm over the Pacific. To understand the scale of Willow Run, one must first understand the people who powered it, the men and women who became, without realizing it, soldiers of production. They came from everywhere: farmers from the Midwest, housewives from Detroit, former mechanics, teachers, and clerks. When Ford announced the bomber project, the call for workers echoed across the country. By 1943, over 40,000 civilians, many of them women, streamed through the factory gates each day. The air inside was thick with noise and purpose. Steel sheets clanged, rivet guns snapped, engines roared on the testing stands. To outsiders, it seemed chaos. To those inside, it was choreography, a human machine guided by blueprints and discipline. Each worker performed a single specific task, repeated endlessly, until the act became muscle memory. Rivet, tighten, pass it on. The workers called it the line that never sleeps. The factory ran around the clock, 7 days a week. Cafeterias served meals in shifts, lights never dimmed, and trains arrived at all hours to deliver parts and carry finished bombers to airfields. At the end of the line, pilots would climb into brand new B-24s and take off directly from the runway outside the plant. Some planes flew to war the same day they were completed. For many of the women, known collectively as Rosies, Willow Run was their first taste of industrial life. They learned to weld, assemble hydraulics, and read engineering schematics once reserved for professionals. What began as a necessity became pride. Every time one of those planes rolled out, one worker later said, "We knew someone's sons might come home because of it." Technologically, Willow Run was unlike any aircraft facility before it. Henry Ford's engineers broke down the B-24's complexity into the same logic that had built millions of Model Ts. Over 1,000 separate subcontractors supplied standardized parts that could fit seamlessly into place, eliminating the painstaking custom fitting that slowed traditional aircraft assembly. Conveyors moved parts down long aisles where workers installed components in synchronized order. A section of fuselage could move through 14 stations before reaching the next department. Precision gauges ensured that tolerances were exact, even under mass production pressure. It was the first time aviation manufacturing was treated like automotive production: predictable, measurable, and infinitely scalable. The impact went far beyond output. It changed the psychology of war. In Europe, Allied commanders began planning bombing campaigns based on an unthinkable premise: that no matter how many bombers were lost, they would be replaced almost immediately. Losses that would cripple another nation were merely statistics to America. Japanese and German intelligence analysts recognized this shift, but struggled to quantify it. How could a single country replace entire air fleets in weeks? To them, it seemed as if the Americans had found a way to manufacture time itself. And in a way they had. Each B-24 rolling out of Willow Run was not just a weapon. It was an hour, saved and multiplied 1,000-fold. The U.S. had discovered the ultimate wartime equation: industrial time equals military power. It was a lesson that would soon confront the enemy in the most brutal way possible, through the roar of hundreds of bombers blotting out the Pacific sky. On the other side of the Pacific, that roar became the sound of despair. Japanese engineers, accustomed to crafting each machine by hand, struggled to comprehend how an aircraft as complex as the B-24 could be built in an hour. In Tokyo's Aeronautical Research Institute, reports arrived describing the American process: photographs of conveyor lines, blueprints showing modular construction, eyewitness accounts from prisoners of war who had once worked in U.S. factories. To the Japanese mind, trained in precision craftsmanship, such scale bordered on heresy. A fighter aircraft was supposed to be the product of master builders, not an assembly line. Yet every reconnaissance photo seemed to confirm the same truth. Thousands of nearly identical aircraft stretching across American airfields like metallic crops, replenished faster than war could consume them. What they could not yet see was the invisible force behind it: logistics. Every rivet, every engine part, every drop of fuel moved through a network so vast it blurred the line between factory and battlefield. Railroads fed Willow Run with materials from the Midwest. Convoys carried the bombers to staging fields. Across the nation, over 900 subcontractors, from tiny machine shops to steel giants, worked in unison. It was this orchestration that stunned Japanese observers after the war. One engineer later recalled, "We could design excellent aircraft, but they could produce the war itself." By 1944, Japan's aircraft industry was under siege. Raw materials were vanishing. Factories were bombed repeatedly by those very B-24s. Engineers tried to disperse production into mountain tunnels and rural workshops, but fragmentation only worsened efficiency. The average Japanese fighter took weeks to build. America could replace one lost over Saipan in less time than it took Japan to assemble a replacement wing. The imbalance was catastrophic, and yet behind the statistics lay something more profound, a difference in philosophy. Where Japan saw war as an extension of spirit, America saw it as an extension of systems. Where Japanese workers built with devotion, Americans built with replication. That difference shaped the skies. In U.S. strategy rooms, generals no longer planned missions around scarcity. They planned around abundance. They could afford mistakes, they could afford attrition, they could even afford failure, because their factories guaranteed recovery. For the Japanese high command, this was incomprehensible. Their entire doctrine depended on decisive victories, fast, overwhelming blows meant to cripple the enemy before industrial momentum could build. But by 1944, that moment had passed. The American machine was awake, and it would not sleep again until the war was over. From the factories of Michigan to the runways of Guam, the distance between production and destruction had collapsed. Each minute in Willow Run echoed across the Pacific. Every 63 minutes, another shadow rose into the sky, carrying with it the weight of American industry and the inevitability of its reach. The Japanese Empire had mastered the art of war. The United States had mastered the manufacture of it, and that mastery was about to change the Pacific forever. By the summer of 1944, the skies above the Pacific had become a moving fortress, where, once the zero reigned supreme, now the air thundered with the deep, relentless hum of American bombers, waves of silver giants stretching horizon to horizon. They came from the Marianas, from New Guinea, from the newly captured fields of Saipan and Tinian. B-24 Liberators, 1,000 strong, escorted by P-51 Mustangs, swept across the islands like mechanical weather. Each carried nearly 3 tons of explosives, guided by crews who knew that for every bomber lost, another would be waiting on the line back home. The Japanese pilots who faced them saw something beyond numbers. They saw inevitability. Dogfights no longer changed outcomes. For every American plane that fell burning into the Pacific, 3 more arrived the following week. Radar operators on the Japanese mainland began to notice patterns. Raids were increasing not just in frequency, but in density. It was as if the Americans were not sending squadrons anymore. They were sending factories into the sky. In Tokyo, General Hideki Tojo's staff gathered intelligence reports with grim disbelief. American bomber production had surpassed 90,000 aircraft per year. Even if Japan shot down 10%, an impossible number, it would make no difference. The empire was running out of planes, fuel, and trained pilots. The enemy was running out of nothing. Meanwhile, in Michigan, the line at Willow Run moved without pause. Inside the mile-long hangar, the rhythm was unbroken. Assembly crews pushing out one completed B-24 after another. From the air, it resembled an organism breathing steel and flame. The logistics behind it were staggering. Over 1.5 million parts per aircraft, sourced from every corner of the nation. Railcars arrived hourly. Inspections ran non-stop. Every component had a serial number, every machine a replacement. The sheer speed of production altered strategy itself. American commanders could now plan campaigns assuming massive, sustained bombardment. Entire fleets of B-24s would saturate island defenses, paving the way for amphibious landings. The aircraft became not only tools of destruction, but the foundation of a new military doctrine: strategic attrition. In June 1944, during the Battle of the Philippine Sea, the power of that doctrine became undeniable. The Japanese Navy launched what it hoped would be a decisive counterattack, deploying its remaining air strength, over 400 aircraft. The U.S. response was overwhelming. B-24s and carrier-based fighters annihilated the Japanese planes in what became known as the Great Marianas Turkey Shoot. More than 350 Japanese aircraft were destroyed in a single day. The shock rippled through every level of Japan's military command. They had not only lost a battle, they had lost the means to fight another. Reports sent to Tokyo described entire airfields obliterated before aircraft could take off, factories burning under continuous bombardment. Even as the smoke rose, more American bombers were on the way. The arithmetic of war had become merciless. For every B-24 lost over the Philippines, Willow Run would replace it in just over an hour. To the men in Tokyo staring at the production charts, it no longer felt like a war between nations. It felt like a war between eras. One powered by hands and the other by machines. By late 1944, that difference between craftsmanship and production reached its breaking point. The U.S. bombing campaign over Japan intensified beyond imagination. The B-24 Liberator, once an experiment in industrial aviation, now filled the skies in roaring squadrons that stretched for miles, from Saipan, Tinian, and Guam. These bombers lifted off in endless rotations, each one carrying the same payload, the same precision, the same purpose. Japanese observers on the ground watched the contrails form like white scars across the sky. The rhythm was relentless. One wave departed, another appeared. It no longer mattered where the raids came from. They simply kept coming. On December 3, 1944, more than 100 B-24s struck Tokyo and Nagoya in coordinated assaults designed to cripple remaining war industries. For the first time, Japan's engineers understood the full scale of what America had achieved. The bombers overhead weren't a single fleet. They were the living proof of a nation's total mobilization. Captured Japanese intelligence later recorded the words of a stunned factory officer. "They produce aircraft like we produce bicycles," and he wasn't exaggerating. At Willow Run, a completed B-24 emerged every 63 minutes. Each day brought 20 new bombers. Each week, nearly 150. No matter how fierce the Pacific resistance, the numbers only grew. Tokyo's engineers tried to calculate the output. The figures defied logic. Even if Japan doubled production, impossible under bombing and material shortages, it would take years to match America's monthly rate. The psychological blow was devastating. Officers began to speak quietly of inevitability. The U.S. had achieved a scale of war beyond human measure, a form of warfare conducted by mathematics, supply chains, and labor. Willow Run was not just a factory anymore. It was a weapon of strategy. The B-24 itself, once considered inferior in maneuverability to the B-17, found its dominance in numbers. Its long range allowed it to reach deep into the Pacific, striking fuel depots, shipyards, and air bases that had once been beyond reach. Squadrons of liberators destroyed Japan's oil fields in the Dutch East Indies, severed shipping lines, and left entire cities without resources. And yet, even as their homeland burned, Japanese engineers could not look away from what the Americans had built. The sheer organization fascinated them. The idea that a machine of such complexity could emerge from an assembly line, identical to the last, powered by the unity of workers who might never see the front. When the Allies captured Saipan, they uncovered Japanese intelligence documents analyzing Willow Run in minute detail. The reports called it the miracle of mechanical war. One entry concluded, "They have replaced the warrior's spirit with the engineer's system, and it is stronger." By the beginning of 1945, the truth was unavoidable. Japan could still fight bravely, but it could no longer fight equally. Its factories were silent, its skies dominated. Its industry shattered under the weight of an opponent that built aircraft faster than war could consume them. The empire's downfall was not written in strategy or courage. It was written in steel stamped by machines and measured in minutes, every 63 minutes. When Japan finally surrendered in August 1945, its cities were ruins, its airfields craters, its factories nothing more than twisted metal. The war had not simply been lost, it had been outbuilt. In the months that followed, Allied occupation forces began documenting Japan's wartime production system. The report shocked even American analysts. Factories that had once prided themselves on craftsmanship were operating with almost medieval inefficiency. Tiny workshops scattered through urban neighborhoods, limited automation, redundant designs. Aircraft were hand-fitted piece by piece. Even critical components like engines and fuel pumps lacked standardization. It was then that Japan's surviving engineers saw the magnitude of what the United States had accomplished. At Willow Run, every part was interchangeable. In Japan, almost nothing was. The Americans had created an ecosystem of manufacturing, not just a factory. Their power had not come from invention alone, but from coordination. In late 1945, U.S. military administrators began inviting Japanese engineers to study American plants and production systems. What they witnessed redefined their understanding of modern industry. The Willow Run concept, division of labor, standardized tooling, flow-line production, became a revelation. It wasn't simply speed. It was structure. One Japanese aviation engineer later wrote, "We realized that the war was lost before it began, not on the battlefield but in the factory. We had built with hands. They had built with systems." This recognition became the seed of Japan's post-war transformation. When the Allied occupation lifted restrictions on industrial rebuilding in the late 1940s, Japan rebuilt differently. Engineers who had once studied B-24 photos now studied Ford's manufacturing blueprints. Universities began teaching production science, efficiency, and quality control. From the ruins of defeat grew a new philosophy, the belief that precision and production need not be enemies. The lessons of Willow Run fused with Japan's innate craftsmanship to create something extraordinary: lean manufacturing. Within 2 decades, the same nation whose engineers once stared in disbelief at American factories would itself become a global symbol of industrial mastery. Companies like Toyota, Mitsubishi, and Honda carried forward the idea that the future of industry lay not in strength alone, but in rhythm, organization, and relentless refinement. Ironically, the blueprint for that miracle had come from the very system that destroyed them, the American wartime machine. And yet, for many Japanese engineers who survived, the memory of those wartime revelations never faded. They spoke not of humiliation, but of awakening. The war had shown them both the terror and potential of industry, how the same force that leveled cities could also rebuild nations. As they studied post-war America's factories, one truth remained impossible to ignore. The same assembly lines that had built bombers could, with the same precision, build peace. And so Japan's engineers began again, not with swords, but with blueprints. By 1946, the remains of Japan's aircraft industry were dismantled under Allied orders. Hangars that once echoed with the clatter of rivets and engines stood silent, but in that silence, a new kind of thinking was forming. American technical teams conducted thorough inspections of Japan's wartime facilities, documenting how the empire's production model had failed. They noted the fragmentation, hundreds of subcontractors scattered across cities, each producing slightly different parts. The U.S., by contrast, had mastered integration. Everything at Willow Run fit together: men, machines, materials, and motion, all synchronized to one purpose. Japanese engineers kept copies of those reports. They studied photographs of Willow Run's production lines as if examining sacred texts. What emerged was not resentment, but fascination. They understood now that power in the modern age belonged not to the nation with the most soldiers, but to the one with the most efficient systems. In the following years, that lesson shaped Japan's recovery. Factories that once built engines for Zero fighters began producing precision machine tools. The same engineers who once designed bomb racks for B-24 interceptors were now designing conveyor systems and robotic arms. Willow Run's legacy took root in unexpected soil. By the 1950s, Japanese engineers had merged their pre-war dedication to craftsmanship, the Monozukuri spirit, with American-style production flow. The outcome was the foundation of what would later become just-in-time manufacturing, a philosophy that would revolutionize the world's industries. In 1953, Toyota engineer Taiichi Ohno studied Henry Ford's assembly principles and the U.S. Air Force logistics systems that had sustained global operations during the war. From these, he built the Toyota production system, a method of efficiency that reduced waste, improved quality, and emphasized continuous improvement. It was the intellectual echo of Willow Run, the same concept, reimagined through a Japanese lens. Meanwhile, in America, the plant that had once produced a B-24 every 63 minutes transitioned to peacetime industry. Ford converted Willow Run into a facility for civilian vehicles, and later for Cold War defense production. But its historical weight remained. It was the place where American industry had proven what human organization could achieve under pressure. For historians, Willow Run stands as both a triumph and a warning. It demonstrated how industrial might could shorten wars, but also how total war consumed entire nations in its logic of production. For Japan, it became a symbol of transformation, a reminder that the same discipline that built bombers could also build a new society. When former engineers from Nakajima and Mitsubishi visited American plants in the 1950s, they spoke with quiet admiration. "The machines are the same," one said, "but now they are building lives instead of destroying them." And in that observation lies the quiet conclusion of the Industrial War. Technology, at its peak, reflects the soul of the civilization that wields it. From destruction, Japan had learned how to build anew, not in 63 minutes, but with patience that would last generations. In the final reckoning, the story of the B-24 and Willow Run is not only a story of machines, it is a story of civilization itself. At the height of war, America transformed its landscape into a vast breathing organism of steel and motion. The Willow Run plant was its heart, beating once every 63 minutes, sending into the sky another liberator to strike at tyranny. Yet beyond its mechanical power lay something deeper, a philosophy that would define the modern world. It proved that wars were no longer won by the valor of individual soldiers, but by the precision of systems, by the invisible harmony between design, labor, and leadership. The men and women who worked the assembly lines were no less essential than the pilots who flew the missions. Their endurance, repetition, and discipline became a new kind of heroism. For Japan, that realization reshaped destiny. From the ashes of industrial defeat rose an entirely new vision, that technology could serve life, not death. The very principles that once forged bombers now built cars, cameras, and computers, carrying Japan into an age of peace through mastery of efficiency. In the end, both nations revealed the two faces of progress. In war, it can consume the world. In peace, it can rebuild it. And as history turns its pages, one image remains eternal: a vast factory floor, glowing under floodlights in the Michigan night, and another B-24 sliding into the open air. Born of human hands and human will, every 63 minutes a machine took flight, and with it humanity learned just how powerful it had become.